sum rule says the derivative of a sum of two functions is the sum of the two derivatives. In other words, when I'm taking the derivative of a sum, I can just leave the plus sign where it is and take the derivative of each piece independently. Just ignoring the plus sign, it stays as it is. So to prove this, let's define the function s of x to be f of x plus g of x, I guess s for sum, and then we're going to take its derivative. So the definition of the derivative says the derivative s prime of x is the limit as h approaches 0, s of x plus h minus s of x all over h. All right. So s of x is f of x plus g of x, and therefore s of x plus h should be f of x plus h plus g of x plus h. S of x, of course, is f of x plus g of x. All right. So now you can see what I'm going to do, really. What I'm going to try and get on this side here is the derivative of f plus the derivative of g. So I'm going to put these two pieces of, these two f's together, the f of x plus h and the minus f of x, and I'm going to put these two g's together, the g of x plus h and the minus g of x. So now I've got the limit as h approaches 0, and I'm just going to rearrange the terms so that the two f's are together and the two g's are together. So f of x plus h minus f of x plus g of x plus h minus g of x all over h. Now, I'm just going to split this up into two fractions. So I'm going to like unadd fractions, if that makes sense. So you'll see what I mean. I'm just going to write it as a sum of this guy and this guy. Because they have the same denominator, right? You add these by leaving the denominator the same and adding the tops. So this is the same as this. And now, of course, this and this looks like the derivative of f, and this looks like the derivative of g. As long as I can take the limit of each one. But that's one of the limit laws that says that the limit of a sum of two things is the sum of the two limits. So we have a limit law that says that this is true. If you have the limit of a sum, it's the sum of the two limits, as long as both these limits exist. But that just means that you can take the derivative of f. To say that this limit exists means that f has a derivative at x. And to take this limit, if this limit exists, that means g, its derivative exists. It's differentiable at x. So as long as you can take the derivative of f and you can take the derivative of g, then it is true that the derivative of f plus g, we did it, it gave us this limit, which is the derivative of f, and this limit, which is the derivative of g.